Now we're going to take a look at three atoms that are very popular in organic chemistry. We're going to see them in different scenarios with a different number of bonds connected to them and a different number of lone pairs. And in each case, we're going to calculate the formal charge for that atom. To start off with, we'll look at carbon. You guessed it. So with carbon, the valence electrons are always the same. That's 4. In this first case, we can see that we have 3 bonds to the carbon. 3 bonds means there are 6 electrons involved, so half the bonded electrons is 3. In this example, there are no lone pairs. So overall, 4 minus 3 minus 0 equals plus 1, the plus being the important part. So this has a formal charge of 1 plus. In the next example, well, it's still 4 valence electrons. Let's count up the number of bonds. Well, there are 4 there. 4 bonds, 8 electrons. Half the number of bonded electrons, therefore, is 4. And still there are no lone pairs. So when we calculate, it's 4 minus 0, which equals 0. This is the neutral case for carbon. Lastly, again, the valence electrons are 4. That hasn't changed. The number of bonds is 3. The number of electrons involved in those bonds is 6. Half the number of bonded electrons, therefore, is 3. Now, if we look here, you'll see there is a lone pair. So we do have 2 electrons from the lone pair. So the calculation is 4 minus 3 minus 2, which is minus 1. So this carbon has a formal charge of minus 1. Next, we're going to take a look at oxygen. So oxygen is in a different group from carbon, so different number of valence electrons. For oxygen, it's 6 valence electrons. And again, in all the cases of oxygen, it's still going to be 6 valence electrons. In this first example, if you count up the number of bonds, you'll see there are 3 bonds. 3 bonds, there must be 6 electrons involved in those bonds. Therefore, half the number of bonded electrons is 3. Looking at the lone pairs, you'll see there is 1 lone pair, and there are 2 electrons in that lone pair. So overall, we have the calculation of 6 minus 3 minus 2, which gives us 1 plus. So this oxygen has a formal charge of 1 plus. The next oxygen case, again, the valence electrons are 6. The number of bonds are 2. So therefore, 4 electrons involved in all the bonds. Half the number of bonded electrons, therefore, is 2. But now there are 2 lone pairs, each having 2 electrons, so overall 4 lone pairs electrons. So the calculation is going to be 6 minus 2 minus 4, which gives us overall 0. This is a neutral oxygen. Finally, again, 6 valence electrons. The number of bonds is 1. Number of electrons in those bonds are 2. Half the number of bonded electrons is 1. Now, rather a lot of lone pairs here. So we have 3 lone pairs. Therefore, there are 6 electrons in those lone pairs. So let's look at the calculation. We have 6 minus 1 minus 6, which gives us overall minus 1. This oxygen has a formal charge of minus 1. Finally, we'll take a look at nitrogen. Nitrogen has a valence electron of 5 in between carbon and oxygen. In the first example, you'll see there are 4 bonds to the nitrogen. 4 bonds involve 8 electrons. Half the number of bonded electrons, therefore, is 4. If we look for lone pairs, you'll see there aren't any lone pairs, making a simpler calculation. So we have 5 minus 4 minus 0 to give us plus 1. This nitrogen has a formal charge of plus 1. In the next case, you'll see same number of valence electrons, so 5. We have 3 bonds going to the nitrogen, 3 bonds, therefore there are 6 electrons involved in those bonds. Half the number of bonded electrons, therefore, is 3. And you'll see there's one lone pair, which must involve 2 electrons. So the calculation is 5 minus 3 minus 2 to give us 0. This is a neutral nitrogen. Finally, our last nitrogen still has 5 valence electrons. Counting the number of bonds, you'll see there are 2. Therefore, there are 4 electrons involved in those bonds. Half the number of bonded electrons is 2. Counting the number of lone pairs, we have 2 lone pairs. Therefore, there are 4 electrons involved in those lone pairs for an overall calculation of 5 minus 2 minus 4 to give us minus 1. This nitrogen arrangement has a formal charge of minus 1.